So as we look today at continuing working with our rules for integration, the thing that we want to focus on here is how would we actually find what that constant is? Okay? And here's the main idea. If we have a derivative and we have a single point on the original function, then we can take the integral and use that point to help us figure out what c is. Okay? Now, let's look at this one as an example here. Okay? If I want to find f of x when I know the derivative and I know a point on f of x, okay, I can take the integral of the derivative, okay? So if I take the integral of 2 sine of x minus the square root of x dx, okay? What's the integral of 2 sine x minus root x? Good. And then plus c. So this is our f of x. Okay? That's our f of x. So now, when we plug in the point, we know this point right here is 0.04. When we plug in 0, we need to make this thing equal 4. Okay? So, as we plug in 0, we get negative 2 times the cosine of 0 minus 2 times 0 to the 3/2 over 3 plus c, and this will all equal 4. Okay? So all I'm doing is plugging in 0 for x and 4 for f of x. Now I can solve for c. This equals 0. But what's cosine of 0? 1. Okay, it's 1. So I now have 4 equals negative 2 plus c. So that means c must equal 6. So therefore, I know f of x is the function negative 2 cosine of x minus 2x to the 3/2 over 3 plus 6.
How again do you know that cosine of 0 is 1?
Unit circle.
Gotcha.
Okay, or if you remember the graph, cosine started up at the top of the amplitude at 1 and then it went down and up. Okay?
Is the cosine of 0 degrees also 1?
Yes. Okay? Now, here's what's kind of cool too, is we can not only do this, but check this out. Let's say I know the second derivative, and I know that at one point, at 0, I know the velocity, and at 1, I know the position. Okay, in other words, I know the function for the second derivative, I know the velocity, or the first derivative here, and I know the location there at 1.
We are going to do the integral twice.
We're going to do the integral twice, okay? You said yay with such enthusiasm. Alright, so here's what we've got to do. Okay, let's take the integral of 12x squared minus 4 dx, and what do we get?
1, 12.
4x to the 3rd.
Yeah.
It'll be 12x cubed over 3, so 4x cubed. What's the integral of negative 4?
Negative 4x.
Negative 4x. 4x cubed minus 4x plus c. Okay? We'll call that cu1 because we're going to do this twice. Alright? So, that is my first derivative. Okay? That's the first derivative. So what am I gonna do here to figure out what C1 is?
Plug in
Plug in.
0 for x and -1 for the answer.
That's right, okay? I'm gonna plug in a -1 for my derivative, and I'm gonna plug in a 0 for x. 4 times 0 cubed minus 4 times 0 plus C1. So that means C1 is -1. And that means that my derivative, f prime of x, is 4x cubed minus 4x minus 1. Okay? So, as Nina said, we're going to do the derivative a second time. Okay? Alright. So, f of x is going to be the integral of 4x cubed minus 4x minus 1. See how this works? Okay? So, and of course I don't want to forget my dx. So what's the integral of 4x cubed minus 4x minus 1?
X to the 4th.
X to the 4th, good.
2x squared.
Minus 2x squared
Minus x.
minus x. And that'll be a plus another c. We'll call that C2. Alright? You could use C and D if you want. It doesn't really matter. There's nothing special about C. So, but we've got to figure out the constant now. So, we were given that a point on this function was the point 1, 4. So, it's going to equal 4 when x is 1. Okay? So that's 1 minus 2 minus 1, so that's a -2 plus c equals 4. So C2 must equal 6. And now I know that f of x is x to the 4th minus 2x squared minus x plus 6. Okay? Does that make sense? Okay. Alright, so take a minute here and try this one by yourself. And then we're going to do one that really gets fun. Alright? It does, trust me. Alright? Alright, so, looking at this, we take the integral, 1/4 x to the 4th minus 2/3 x cubed plus 3x plus c. You plug in a 0 for x and a 2 for y, or f of x, and you figure out c equals 2. So therefore, our final answer here is that f of x equals 1/4 x to the 4th minus 2/3 x cubed plus 3x plus 2. Okay? Nice job. Alright, now, you might be saying, like with the last one, where we had the second derivative, you might be saying, well, how in the world, how would we do that if we didn't know what the velocity was at a given point, okay? For example, you guys know that the acceleration of an object flying through the air is negative 9.8 meters per second squared, because that's gravity, okay? However, you may not be able to measure its velocity at a given moment, but you might be able to identify 2 locations where it's at. Alright? So, a similar concept is right here. If we know the second derivative is 3x squared plus 10, and we know that 2 of the locations this thing is at are at 1, 1 and 2, 61, then what is the actual function? Alright, notice we don't know anything about the velocity at this point. All we know are 2 different locations. Alright, so check this out, okay?
You have to take the integral of 36x squared.
Wait, is this
plus
That's right.
10, And then the integral again?
We're gonna take the integral twice again, but notice here, if we do the integral here, we get 36x cubed over 3, which is a 12x cubed
Plus 10.
plus 10x plus c. Now that is the first derivative. What's c? We don't know. But that's okay. We can still take the integral of this because c is a constant, right? And we can take the integral of a constant. So now we could take the integral of 12 to get f of x, take the integral of 12x cubed plus 10x plus c with respect to x. What do we get here?
So we get like 3x4
3x to the fourth.
plus what?
5x squared.
10x squared over 2 is 5x squared, good.
Plus cx.
Plus cx, and I'm going to use a plus d as my constant for this one.
Oh no.
Okay? So here's the thing. This is why we had to have 2 points on the curve. What are we going to make here? A system of equations. Alright? So check this out. This is f of x. So I know that when x equals 1, our function equals 1. So 1 equals 3 times 1 to the fourth plus 5 times 1 squared plus c times 1 plus d. Okay? Alright, so if we simplify this, we get 1 equals 3 plus 5 plus c plus d. So that's an 8, so negative 7 equals c plus d. There's one of our equations for our system. Okay? The other equation we're going to get by plugging into point 261. Alright, so let's do that here. Okay? It equals 61, not 16. 61 when x is 2. So 3 times 2 to the fourth plus 5 times 2 squared plus c times 2 plus d. Okay? So 3 times 16 is 48 plus 20 plus 2c plus d equals 61. 48 and 20 is going to be 68. Okay, we subtract, we get a negative 7. Okay, we get a negative 7 equals 2c plus d. Huh. Okay,
Is C
Ew,
0
I
then?
don't look, I don't
so
like that.
actually good, that's good logic right there.
Thank you.
C has to, in order to add c and get negative 7 and then add 2c and get negative 7, c is going to have to be 0.
Right.
Okay? Now, if you didn't figure out logically, you could do it by either elimination or adding or
So D is negative
substitution.
7 and C is 0.
So D is negative 7. And C must equal 0. You guys know how to solve systems even if you didn't figure that out logically, but that's great right there. Okay? So, look at our final function. F of x is 3x to the fourth plus a 5x squared. Watch this. C was 0, so there's no linear term. It's just 3x to the fourth plus 5x squared minus 7. There's our original function.
It's not that
Okay?
Did you use substitution?
So, this is where it gets interesting. And believe it or not, actually, though, this is a little more realistic than our first one that we did with where we had to do it twice. Because it's a lot easier to find locations than it is to figure out instantaneous velocities, unless we've got a little radar gun shooting it at something, you know, to figure out how fast it's going. So this is actually a little bit more realistic of how you could, if you know the acceleration, get to an actual model for the thing.